Hey there! In this video, I'll share with you two easy methods to perform moles, mass, and number of particles conversions. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Let's begin with the conversion factor method followed by the cross multiplication method to solve our problem. Scientists have found a standard way to talk about a set amount of particles, which could be atoms, ions, or molecules, very small and weigh very little, and that is with use of the term mole. Now, similar to the concept of 1 dozen, where 1 dozen apples will be equivalent to 12 apples, 1 mole of any particle will have 602 hexillion particles. Now there's a much simpler way to write this number, and that is using scientific notation, where we take the first digit in a number that is between 1 and 9, followed by a decimal point and the other numbers. We then multiply that number times 10 raised to a certain exponent. Therefore, 1 mole can be written in scientific notation as 6.02 times 10 raised to the power of 23. Also, this mole concept started with the carbon-12 isotope, and the theory is that 1 mole of any substance has the same number of particles as there are in 12 grams of the carbon-12 isotope. The carbon-12 isotope has atomic mass unit 12, and to get the number of moles, we simply change atomic mass unit to grams. So, if we look in the periodic table, we will find that the atomic mass unit for sodium is 23. So the mass of 1 mole of sodium atoms will be 23 grams. When using the conversion factor method, we need to multiply the number given in the question, 46 grams of sodium, and we need to multiply this number with the unit by a fraction, which will enable us to get rid of this unit and end up with our answer having the unit that we want based on what the question asks us for. So let's start with two statements, and we're going to write them here concerning the theory behind this question. So we know that 1 mole, and this is the short form of the word mole, of sodium atoms will weigh 23 grams, and we also know that 1 mole of sodium atoms will have the amount of particles that is equivalent to this number, also called Avogadro's number or Avogadro's constant, 6.02 times 10 to the 23rd atoms. Okay, so now we need to multiply this 46 by a fraction that will cause us to get rid of this gram and end up with atoms. Any number multiplied by itself is the number. So 46 times 1 is 46. And written as a fraction, 1 can be written as 1 divided by 1. But let's write this statement in terms of fraction to first convert grams to moles, and then we'll deal with the other statement later. We can write any of these two numbers as the numerator at the top of the fraction, either the 1 mole or the 23 grams. Since we want to be able to cancel this unit here, grams, then we would put the 23 grams as our denominator. So times 1 mole divided by 23 grams. We could have written this fraction the other way around, but it would not enable us to cancel our units. So let's do some work. So this gram cancels that one. 46 times 1 is 46, and we can even cancel here. So we'll do 23 into itself is 1, 23 into 46 is 2, and so our answer is 2 moles of sodium atoms. Now, let's use our second statement to make some mathematical moves that are simple and easy to follow and will enable us to get the answer that we're looking for, which is the amount of atoms there are in 46 grams of sodium. So we start with our 2 moles. And we multiply that by a fraction that will enable us to cancel the unit here, mole. And this statement has 1 and Avogadro's constant. Now we'll put the 1 mole as the denominator. So that's 1 mole. And we'll put the Avogadro's constant as the numerator. So 6.02 times 10 to the 23rd atoms. Now, this unit cancels that unit, so the moles are gone, and we are left with 2 times Avogadro's constant, which is 1.24 times 10 to the 24th power sodium atoms. Now let's use the method of cross multiplication. For this we will need 2 statements, and if statements that will come from the theory, and a then statement which will come from the question. Okay, the if theory comes in from these 2 statements here, and that is 23 grams of sodium will contain Avogadro's number amount of atoms. So if 23 grams of sodium has 6.02 times 10 to the 23rd atoms of sodium, then, and this comes from the question, 46 grams of sodium contain an unknown amount of sodium atoms. Notice that I was careful enough to put the grams on one side, this side, and the atoms on the other side. And this is a way to ensure that my mathematical statements are logical and sound and clear. Now to cross multiply. So the 23 will multiply our x here, which is unknown. So 23x is equivalent to 46 times Avogadro's number. 46 times 6.02 times 10 to a power of 23. And to solve for x, we'll simply divide both sides by 23. So those go away there. So we are left with x on the left hand side. On the right hand side, we have that product divided by 23. We can do some cancelling there, and we end up with 1.24 times 10 to the 24th power sodium atoms. Remember that mathematics is a language and there are multiple ways to solve these problems. But what we've used today are two of the well-known methods for mass mole number of particles conversions. And our answer is 1.24 times 10 to the 24th number of sodium atoms. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to use the conversion factor method to multiply the quantity given in a question by a fraction that leads to the correct answer and unit, or the cross-multiply method to make simple if and then statements and basic mathematics to solve the problem with the correct unit when doing conversions of moles, mass, and number of particles. Good luck on your exams, and I'll see you next time.